Hello. This podcast is an introduction to circular motion. Specifically, we're going to talk about the basics of curved and circular motion, what is required to keep an object moving in a curved or circular path, what happens if it is removed, is it accelerated motion, what is centripetal force, and finally, what is the radial dimension. Let's get started. What is required to keep an object moving in a curved path? Well, let's take a look at Newton's first law. An object in motion will continue to move in a straight line unless an unbalanced force acts on it. So that law tells us an unbalanced force acting perpendicular to the object's motion will cause an object to move in a curved path. Let's look at two examples, a car going through a curve and a tether ball going in a circle. First, we have the car going around a corner. We will go ahead and do our force diagram. So we draw in the normal force and the force of gravity. And we have the friction force between the road and the car's tires. And the vertical forces are balanced. Now, the force that's causing the car to go in a curved motion rather than the straight line is this friction force. Notice it is unbalanced. Let's take a look at the tether ball. We have the tension force of the rope, and we have the force of gravity, earth acting on the ball. Now, the tension force is not on the x or y axis, so we need to break it into its vertical and horizontal components. So we have the F sub tx, or the horizontal component of tension, and we have F sub ty, the vertical component of tension. The vertical component of the tension force balances the gravity force, and notice the unbalanced force is the tension force in the horizontal or x component, and that is the unbalanced force that keeps the tether ball going in a curved or circular motion. What happens if this force disappears? Well, again, we can refer back to Newton's first law. An object in motion will continue to move in a straight line, and if we remove that force, the object will go in a straight line. So let's take a look at our two examples from the previous slide. And this time, let's say the car hits a patch of ice and the tether ball rope breaks. In each case, that will remove the unbalanced force. So here we see in this example, the car is moving around the corner and all of a sudden the friction force disappears and because it's on the ice, and the car will move in a straight line. With the tether ball, again, we have the rope, and if the rope breaks, the ball will go immediately in a straight line. Is curved or circular motion accelerated motion? And the answer is yes, and here's two pieces of proof. One, unbalanced forces cause accelerations, and curved and circular motion requires a constant unbalanced force. Therefore, it must be accelerated motion. The second piece of proof is an object moving in a curved or circular path is constantly changing direction. Velocity has both magnitude and direction. Therefore, if the direction is changing, the velocity is constantly changing, and this is the definition of acceleration, change in velocity. What is centripetal force? Centripetal force is the name for the unbalanced force or group of forces acting on an object that cause it to move in a curved or circular path. It acts perpendicular to the object's motion, and it always points towards the axis of revolution, also known as the center of the curve or circle. So let's take a look at our car here and draw our force diagram again. And I have the friction force in red here because this fits the definition of the centripetal force. It's unbalanced and it's perpendicular to the motion of the car, because the car is coming straight at us, and it points towards the center of the curve. So in this example, the friction force is the centripetal force. Now, let's take a look at our tether ball, and we'll draw the force diagram again. And notice I've highlighted in red the horizontal component of the tension force. That's because it fits the requirements for centripetal force. It's unbalanced, it's perpendicular to the motion, because in this instance the tether ball is going away from us behind the screen, so it's perpendicular to that motion, and it's pointing towards the center of the circle. It meets all three requirements for centripetal force. Another way of thinking of the centripetal force, and this is really important, think of the centripetal force as the net force in the radial dimension. In fact, I would prefer to forget about the centripetal force term and just call it the net radial force. However, textbooks and professors in your future courses will refer to centripetal force. But it's not a specific force, it's the net force in the radial dimension. Okay, so what is the radial dimension? Well, we've got a circular path here to the right, so let's talk about this. We can't, first of all, think in terms of vertical and horizontal dimensions. Up until this point, we have. Instead, we need to think in terms of radial and tangential dimensions. So let's look at what they are. First, the radial dimension starts at the center of the circle and extends through and past the object. So here, for the 4 different positions of the ball moving in a circle, I've shown the radial dimensions. The tangential dimension is perpendicular to the radial dimension, and it's tangent to the object's circular or curved path. And now let me draw the tangential dimension. Notice that the dimensions move with the object. When the ball is at the bottom of this circle, the radial dimension is vertical and the tangential dimension is horizontal. But as we move to the right, and when the ball's on the right, we notice that the tangential direction is vertical and the radial dimension is horizontal. So these dimensions move with the ball. And I'm just showing 4 different points on this circle. You could put the ball or the object at any point in this circle, and the radial dimension will start at the center and run through the object and beyond the object, and the tangential dimension will be the tangent line to the ball at that specific point in the circle. And finally, the instantaneous velocity is in the tangential dimension. So now we know that with centripetal force, it's a net force in the radial direction. So the centripetal force and centripetal acceleration act in the radial dimension, and the velocity of the object acts in the tangential dimension. Let's go ahead and summarize what we've learned. An unbalanced force acting perpendicular to the motion of an object will cause the object to change direction. The object will follow a circular path as long as this unbalanced force is applied. Removing this unbalanced force causes the object to immediately move in a straight line. This unbalanced force or group of forces is called the centripetal force. And finally, and most importantly, the centripetal force is not a specific force, rather it is the net force in the radial direction. I hope you found this helpful, and have a good day.